This slab can be classified based on its span. The span that is having two types of dimension. One is length, another is breadth. So one is your longer span, another is your shorter span. So this longer span is considered as Ly, is denoted as Ly, and shorter span is denoted as Lx. So the ratio of this Ly Lx gives us these different types of slab. That is one is one way slab and another is your two-way slab. So we have basically this two types of classification, two types of slab that we find based on their dimensions. Beside the regular slab that we find, we have another type of slab that is called flat slab. Flat slab is actually a type of slab where we don't have any beam to support the slab. Means the load of the slab is directly transferred into the column itself. But in conventional slab that we see, the load of the slab is transferred to the beam, and from beam that is transferred to the column. So how this slab is classified based on the dimensions? The criteria is when the ratio of this longer span by shorter span is greater than 2. Means when the larger dimension is more than the smaller dimension, then that is called one-way slab. Okay, so we can say that this type of slabs are spanning in one direction. Okay, now since these slabs are spanned in one direction, means they are more of, we can say, a rectangular. If you see a plan, we will find it is rectangular in shape. The one-way slab means the length, the value of Ly, the length of the largest length of the slab is more than the shorter length, shorter span. So since it is rectangular in shape, so the bending that which will takes place, it will be placed along the shorter span. Okay, so this is the significance of the one-way slab, where the bending takes along the shorter span. So since the bending takes along the shorter span, so we have to provide the reinforcement along the shorter span only. Okay, and while analyzing this type of one-way slab, we have to assume to consider the slab of having a 1 meter width. Considering a 1 meter width, we will design the slab and it will be analyzed. So if you see the figure here, as you can see, the one-way slab, which is more of a rectangular in shape, the longer direction Ly is more than twice of the shorter span direction. So bending will be more over to the shorter span, and if you see the support condition, two beams are being supported through the longer span. So this is how the bending takes place only in the shorter direction. If you see the bending moment diagram. But on the second case, for two-way slab, the condition is that the ratio of Ly by Lx should be less than equal to 2. Okay, where the bending takes place along both the direction. Okay, so the significance of two-way slab is that the ratio should be less than 2. The ratio of Ly by Lx should be less than 2, and the support condition, if you see the difference between the support condition for two-way slab, is that we have 4 edges. The 4 edges are being supported, and the ratio is also quite near around your square type. If you see the plan of a two-way slab, since the ratio is less than 2, the L/Lx ratio, so we have to support the 4 edges, and because of this, the slab is called spanning in 2 direction, unlike your one-way slab. And here also bending takes place in both the directions, both the shorter and longer directions. So for this, it can be concluded that the reinforcement is to be provided in both the directions, means both the shorter and longer direction. So we say the reinforcement is to be provided in both the directions for two-way slab, and the reinforcement that is provided is called main reinforcement. This main reinforcement is provided on both the directions. Okay, all of you have understood this? Now let us discuss about the load distribution in slab. So to consider the load distribution, we have to consider a point P, which is a part of a strip, a rectangular strip. As you can see in the figure, if all the edges are supported and we have a strip AB and CD, then for the slab which is loaded by a UDL, that is omega per unit area or W per unit area, and we consider the longer span as Ly and shorter span as Lx. So for this strip AB and CD, considering the longer span Ly and Lx along the Ly and Lx, so we can say that Wy is the load that is carried by the slab along the longer direction, and Wx, let us consider, is the load that is carried, the UDL that is carried per unit area in the shorter direction. So the total load that is carried will be W is equal to Wy plus Wx, and the deflection of this center point P for this strip AB and CD, we know that the maximum deflection for the fixed portion, fixed beam that we have considered as a strip, we can say the formula of the maximum deflection at the center point is, due to UDL, 5 by 384 Wx L to the power 4 by EI. Now if we equate these two equations, because the deflection point P is same for both the cases, for both the strip AB and CD, so by equating we can find, we can have the value of Wx in terms of Ly and Lx. So Wx turns as Wy into Ly by Lx to the power 4, and substituting the value of Wx in the equation, that is, so W is equal to Wy plus Wx. So Wx, equating this, we get in terms of Wy. So we get the value of Wy and Wx both in terms of W and Ly Lx. So W by 1 plus Ly by Lx to the power 4, and Wx is equal to W into Ly by Lx to the power 4 by 1 plus Ly by Lx to the power 4. So from here we can find, if we have the total load, so individual load of each direction, the load carried by each direction can be find out. Okay, understood? I hope it is clear. Now let us consider different values of Ly by Lx. So for 2A slab, when the values are less than 2, the ratio that is less than 2, that is, it could be 1.5 or 1, the ratio of Ly by Lx. So for that you can see that the values of Wy and Wx are turning as 0.16 W and 0.84 W. Whereas when it is about 2 and more than 2, then we will find that the value of Wy and Wx are in terms of 0.05 W and 0.95 W. But when the value of Wy and Wx is 1, then the values of Wy and Wx are half of the W. So the distribution is equally among W1 and Wx when the strips have equal dimension, when the span of the dimension of the slab is equal, means Lx and Ly value is same, then the loads are equally distributed. Whereas when we have more than the ratio of Ly by Lx more than 1, you can see the maximum portion of the load, that is, if you see for 1.5 Ly by Lx 1.5, the value of Wx is equal to 0.84, and whereas Wy is 0.16 W. So the maximum load is carried by the shorter span, and whereas when you reach 2, the ratio as 2 means when the length is twice of the breadth, then the slab, you can see that almost 95% of the load is carried by the shorter span. So 0.9, this indicates that that is why for the stability of any slab, for any structure as a whole, we can say we actually consider that we have to make sure that the beam must be as much as close to the one-way slab. That is ideal, because the distribution of the load will be equally along the two different directions. But when we prone to more rectangular in shape, when the dimensions are on the largest length is more compared to the shortest span, then you can see that it is the shorter span load distribution is drastically increasing. So it is always preferable to use two-way slab, and it is always advantageous compared to your one-way slab. So it is well evident from this equation. Okay, I hope it is clear to everyone. Now from this, we can draw some conclusion, as just I have told. When the ratio of this Ly by Lx, when it is more than 2, equal to or more than 2, means for one-way slab, the load carried by the shorter span is almost 95% compared to the longer span. So there is a extra pressure on the shorter span. We are giving extra load that is carried by the shorter span due to the one-way slab criteria. So while designing the slab and while considering the support on the two edges, due to the two edge support, the bending will be only one direction, that is shorter direction. Okay, and when on the other case, when it is less than 2, then the load is equally shared by both the shorter span as well as the longer span, because the bending takes place in both the directions. So when this, due to this one way action of the slab, so we see that the maximum bending moment that is carried by the shorter span takes large bending moment, and that is because of the shorter span only. So for two-way slab, that is when the distribution of the load is in both the directions, so the bending moment becomes smaller. So this is the advantage of the two-way slab. So when the question is asked to why the bending moment is smaller compared in two-way slab compared to one-way slab, so the reason is the distribution of, because of the load distribution in both the direction in two-way slab. So because of that, we can have a smaller bending moment. Whereas for one-way slab, due to the shorter span which is carrying the maximum bending moment, so there is a larger deflection, and hence the largest bending moment is found in the one-way slab because of the shorter span, and since the support is only in two directions, not in four directions. So because of this maximum bending moment that is find in the one-way slab, so that also affects the depth of the slab. So the depth of this slab, so because you have to counter the maximum bending moment in the shorter direction, in the shorter span, and for the one-way slab, so we have to increase the depth of the slab. So you can also see that the depth of the one-way slab is more compared to the depth of the two-way slab, and that is because of the maximum bending moment that is carried by the one-way slab. Okay, I hope it is clear to everyone. Should I repeat any part, or it is clear to everyone? Okay, let me briefly discuss about the difference between one-way slab and two-way slab. So as we have seen the criteria that in one-way slab, the longer to shorter span ratio, that is Ly by Lx, should be more than 2 for one-way slab, whereas for two-way slab, L by Lx ratio should be less than equal to 2. Okay, in one-way slab, the bending will take place in one direction. Okay, because of the shorter span that is present, and that is only in the shorter span. Whereas the bending will takes place in both the directions for two-way slab. Okay, the third point for one-way slab is depth required. The depth of the slab will be required more compared to the two-way slab, and in two-way slab the depth required will be less because the distribution of the load is in both the directions, shorter and longer. Fourth point is the main steel reinforcement is provided along the shorter span. Okay, because the shorter span is taking the maximum bending moment, so our main reinforcement is to be provided along the shorter span only for the one-way slab, whereas for two-way slab the main reinforcement is to be provided for both the spans, both the longer span and shorter span. Okay, so from here it is clear which one will be more economical and which one will be less economical. So this one-way slab, since because of the ratio L by Lx ratio, maximum ratio, that is more than 2, so there will be more requirement of depth, so there will be more requirement of materials, so that is why it is less economical. Okay, because the thickness is more, and as well as due to maximum bending moment, the steel requirement, the reinforcement that will be required is also more. So compared to two-way slab, one-way slab will be more expensive, that is it will be lesser economical. Whereas in two-way slab, because of the distribution of the load which is uniform, which is in both the directions, both shorter and longer directions, so that is why the thickness of the slab will be lesser. Since the bending moment is less, so less steel means still less reinforcement will be required. So because of that, it is more economical. Means it is compared to cheaper. It is comparatively cheaper with respect to the one-way slab. Okay.